Okay, we're finishing up chapter 7 with a brief review of complex fractions. So here you see 1 through 7. We're going to do some sampling of it. Complex fractions. By definition, it's when you have a fraction in the numerator and a fraction in the denominator. Now, if you look at this, it's saying this fraction divided by this fraction. So if you see something like that, the best way to treat it, and let's show you what it's like here. It's going to be A over B divided by C over D. And what you're going to do is change it from this form so that it looks like A over B divided by C over D. And the rule for that is you take the division sign, change it to a multiplication sign, and you take the reciprocal, that is, flip that. And then you can cross-cancel wherever you can, and that's how you do it. So basically, in rewriting this is going to be 4x over 45 times, flip the bottom, 25 over 12x. So as we do this now, we see we have common factors. And I'll change colors. We have 5 will go into 25 5 times. 5 will go into 45 9 times. The x's cancel out. 4 goes into 4 once. 4 goes into 12 3 times. And there's no other common factors. So this will become, in our numerator, 5. And then 3 times 9, 27. And you can't reduce it anymore. So once again, when you have a complex fraction in this style, a fraction over a fraction, just change it from division to multiplication, take the second term, flip it, and cancel out wherever you can. So as we rewrite this one, this is going to be 2x squared y over 3xz times, now the xz goes on top as we flip it, and it's just then a multiplication problem. That's a z, so these will cancel out. And I don't see a lot, oh yeah, the 2 here will go once, and here it will go 3 times. So what you're left with then, on the bottom, is a 9, and then on the top, x squared y. Once again, you have a fraction over a fraction. This is divided by. You change the divided by to multiplication. Flip this term, cancel out wherever you can. Now in example 5, it's a little different. There are fractions, but there's 2 fractions up there. So for this, we use another method. The other method is to multiply numerator and denominator by the lowest common denominator of both sets of fractions, here and there. So as you look at it, what is the lowest common denominator of this one and this one, such that it would get rid of all those fractions? Well, we know we need an A. And then we're going to need a b, but which power of b? Well, b to the second. So we're going to multiply then each term by this. And that should get rid of all of our fractions. So it's this term times this. And you see the a and the b's cancel out here, and you're just left with a b there. So this will become 4b. You're multiplying this term by this. These cancel out, and you're left with the b. 4 times b minus, now the b squares cancel out, and you're left with a negative 3a. Now on the bottom, the a cancels out, and you're left with a b squared. This a cancels out. You're left with a 1 times b squared plus one of the b's cancel out, and you're left with 3ab. Now as you look at this, can you cancel anything out there? No, you could factor a b out of here, but it's not going to cancel, so you can leave it like this. Now the same thing applies on the bottom one. What will be your lowest common denominator for both of these denominators? Well, here we have an a, here we have a b. So our lowest common denominator will be AB. AB. And what we're going to do now is multiply through to get rid of our fractions. So nothing to cancel out here, so this becomes a squared b plus, here the a cancels out, and you get a b squared. And again, here, nothing to cancel out on this first one. So this becomes a b squared plus, now the b cancels out. The b's would cancel out and you get a squared. So as you look at this, what's going on here? Well, we have complex fractions. And what we want to do with these fractions is simplify them. And we do so on this side by just treating this as a division of fractions where we convert it to multiplication and simplify. But here, when there are two terms, you can't use this technique. So the technique you use is multiply each of these. Remember, these are 1 over 1. This divided by this is 1. We're allowed to multiply anything by 1 and not change its value. But we're using this technique to get rid of these fractions, as we've illustrated here. Okay. Now in number 11, as we look at this, this is something a little different. We have some negative exponents. So in order to set this up as a complex fraction, we have to do some translation here. Now, in a sense, this is a 1 over 1 there, and this is over 1, and this is over 1. And you may recall the rule that anytime you have a negative exponent, depending where it is in regard to this division bar, All you have to do is take it down across this division bar, and this becomes a positive exponent. So x to the negative 2, in a sense, is 1 over x to the second. And we do so by taking it from where it is, cross that division bar, and the exponent changes its sign. So then this one's going to be 2, and you can put it over 1 if you'd like, minus, and again the 1 is up there, this is going to be x to the negative 1, which becomes x to the first. We don't write the 1, but it's translating from how it appears to something now you can work with. And what we're going to do is, again, that same technique, multiply numerator and denominator by our least common denominator and see if you can figure out what it is. Well, it's x to the second. So what does it become? Well, here it cancels out completely, and we just get a 1. And again, they cancel out, but the 1 is still there. And then now you have nothing to cancel out here. This becomes 2x squared. Here, one of the x's cancel out, and this then will become a negative x. Now you could factor out an x from here, but it doesn't do anything, so leave it like so. Now this next one's sort of a challenge. We jump to number 14. There are other examples that are similar. I'm going to erase this here so we get a little more focus on what we're doing. This is really a complex fraction, but it's treated the same way. What is our lowest common denominator here? I want to just check the signs to make sure I copied it down correctly. This was, yeah, this is going to be a plus here. Okay, that's good now. I don't know if you see this, but these are conjugates from earlier lessons. And conjugates, when you multiply them, become the difference of perfect squares. So this factored into these two binomials. So our least common denominator then will be this, that I'll write as x plus 3, x minus 3, x plus 3, x minus 3. Probably should have had this over here, give me a little more room. But let's see what we get. In fact, what I'll do is I'll put it underneath here. So here, this one will cancel with this one, so I'm left with this. So I'll write it out. 2 times x plus 3. Now I'm going to make this a plus, make that a minus, easier to work with. Now this one cancels out with this one, so I'm left with a negative 3 times x minus 3 on top. Now on the bottom, all of this will cancel with this, so this is gone, and I'm left with a 5, and I'll make it like so. And now this one cancels with this one, So I'm left with a negative 2 times x plus 3. So we went from something very complex by using this technique of getting rid of the fractions, and now we just have to simplify. So as we distribute, we get 2x plus 6 minus 3x plus 9 all over 5 minus 2x minus 6. So it's a matter of now of collecting like terms. Here we're going to end up with a negative x and a positive 15. And then here we're going to end up with a negative 1 and a negative 2x. So checking our work, this is a negative 1, positive 15, a negative 1, and a negative 2. So from all of this, we end up with something like that. Okay, so again, complex fraction. We're going to look for our lowest common denominator. To get rid of all of our fractions. Well, looks like we did this one already because it seems very familiar. A b squared. A b squared. So we're going to cancel out the a and one of the b's, so we're left with the b minus 3, cancel out this, 3a. Here we cancel out the a and we're left with a b squared. And we cancel out the b and we're left with a negative 3ab. Again, it seems like we did one very much like this. And that one was easy, number 16.